We're here at the top of page 2 of 1.5, and in this section we're talking about adding real numbers. The focus here is on positive and negative numbers, all the different combinations of adding those two. And we're in the part where we're bringing in the fractions and the decimals, okay? But the rules stay the same. And again, if you need extra help with fractions or decimals or going in between the two, get that right away at the beginning of the term. Come to me, Student Learning Center, other tutoring options. Aren't sure where to go? Check with me. We also have that help resources page on our syllabus. So here at number 44, let's just do a quick recap. The method that I'm demonstrating here in these notes, it's not the only way to do it, but the method I'm demonstrating is if the two signs are the same, we add them together. So same signs, you come up with the sum, and you keep the bigger sign. If the two signs are different, you find the difference. So it's a nice little pattern here, same, or a nice connection. Same, sum, different. Find the difference, which means you're going to subtract. And again, you keep the bigger sign. Now, I put bigger in quotes here. I'll do it with the previous one as well, because it's not really the bigger number in terms of the greater number on a number line. It's bigger just when you look at them without the signs, which one would be bigger. And just to help our brain in terms of memorization, I put both rules as keep the bigger sign. Really, it's just keep the sign on the sum because they're both the same. But we want to do everything we can to help our brain remember stuff. So, same sum, different difference, keep the bigger sign. Okay, so as we're looking at number 44, what if it starts to add a bunch more numbers in? Okay, what's different here is there's 4 things to add. 2 fractions, 2 integers, but even though it looks different, it has more things involved, the rules don't change. That's what you really want to grab hold of, is so that you're really convinced that the steps you used previously while the problems were easy, now as the problems get harder, those same steps still work. So you get to push yourself and grow in your mathematical skills here. Now, we can also utilize the idea that with the properties from 1.4 of commutative and associative, so use the properties from 1.4, especially the commutative property, I can switch these around. I can add together, I can switch the negative 7/9 and the 35ths, and I can make this problem negative 50 plus 35 plus negative 7/9 plus negative 11/9. I'm just going to pause here for a quick mini lesson on fractions. A lot of people ask, does the minus go out in front? Does it go on top? Does it go on bottom? Remember that one of the things we're working on this term together is that when we see a negative in front of something, we think of it as being multiplied by -1. So in that case, that -1 can be multiplied out in front, 1 on top, or 1 on the bottom. It really doesn't matter where that sign goes. Typically don't see a finished version with the negative on the bottom. Typically we see a finished version with the negative for a fraction on the top or out in front. So all those mean the same thing. What doesn't work is to see a negative out front and put it on both top and bottom, okay? Because then you'd have a negative to start with, but a negative top and bottom would be negative divided by negative. You'd end up with a positive, okay? So just a little mini lesson. I'm happy to go over that individually with you as it is helpful to you. So let's look at these first 2 problems, because we know what to do when we're adding 2 numbers with either same signs or different signs. So in this case, negative 50 plus a positive 35, the signs are different. So that means we're going to subtract. So we take 50 minus 35, that gives me 15, and we keep the bigger sign here. The 50 has the negative, 35 has positive. So we put a negative 15, bring down our plus sign that separated the 2 halves of this problem. And I've got negative 7/9 plus negative 11/9. Super glad that I've got like denominators all ready to go. So I just get to do top plus the top. So I'm at negative 7 plus negative 11, the whole thing over 9. these are same signs. So I'm going to add 7 plus 11 is 18, and that is, and keep the bigger sign, which it really doesn't matter because they're the same here. So 7 plus 11 is 18. Keep the bigger sign, that's going to be negative. It's still a fraction, 18 over 9. This is then going to reduce to negative 2. So I've got the negative 15 from the left side here. I've got plus a negative 18 over 9, which is a negative 2. And then I've just got one more to solve here. Both signs are the same. So I'm going to add, or find the sum. So that gives me 15 plus 2, that's 17. And then I keep the bigger sign. Doesn't matter when they're the same because you just keep the sign. Okay, but if you say keep the bigger sign every time, you'll never forget when it's time to subtract. That's the point of doing that. Okay. I am all about whatever it takes to get your brain to remember stuff, because you want to have it so solid that when the exam comes along, nothing can panic you into doing the wrong thing or making up new math. All right, let's look at this next two set of problems. I'll do 2 examples here, and then the try will be on the next video. Simplify each algebraic expression. So again, when we're talking about simplifying here, we have 2 goals. One goal is to remove any parentheses. Sometimes that will be multiplication, sometimes it'll be multiplication over addition. We know that now to be distribution. So sometimes you might have to distribute to get rid of parentheses. The second thing is to combine like terms. And you want to look for them in that order, okay? Because with order of operations, you'd always look to handle any grouping things first. So we want to remove any parentheses. You'd use distribution to do that if you have to, and then combine like terms. So as we look at 48, kind of the beginning type of these problems, a little bit less of a challenge, just kind of getting you warmed up to it. We look, and there are no parentheses, no groups of any kind. Then we look for like terms. And yes, it does have like terms. And again, how do I know? Because the variable is exactly matching, x and x, and they both have the same exponent. This is really x to the first. When you don't see the exponent, it's to the first. Okay? So what I'm doing here is I'm going to be adding these 2 terms together. So here now we get to apply our skills for adding numbers, positive and negative numbers, but now we're involving variables, okay? So if it had been 19x plus 10x, I'm guessing many of you would feel very comfortable with saying, great, like terms, 19 plus 10 is 29x, okay? So we're going to apply that same concept, only this time when it's going to have positive and negative numbers here. So we're going to be adding 19x and 10x. It's just that the 19 is negative. So we go through the same steps we've been doing this whole time. Don't make up new math. Don't assume you don't know how to do it here. Okay? If it had been just negative 19 plus 10, no x's involved, you would say, great, different signs, we'll subtract. 19 minus 10 is 9. Keep the bigger sign. Answer is negative 9. So same idea here. It's just there's an x involved. So different signs. So we're going to subtract 19 minus 10, and that gives us 9. We're going to keep the bigger sign, negative 9x, okay? Because you've got 19x minus 10x equals 9x, and then we just keep the bigger sign there, negative 9x. Okay? And, you know, you'll hear me say it lots and lots. The way I do them in the notes is to talk through every little step possible as we're covering new topics. So when you get to the practice sets and you're doing the problems on your own, you may not have to show as many steps as I do. You need to show enough to convince me that you worked the problem, didn't just look it up in the back of the book. But you may not have to do as many steps. Especially as you get through the assignment, you're going to start to see patterns and notice things and kind of have some aha moments where you'll be able to speed things up, maybe do a little bit more in your head. As long as you're still getting consistent answers and you're confident about what you're doing, then showing less work is going to be fine. But as soon as you start hitting some bumps. You're either getting a few wrong, you don't know why you got them wrong, or you thought you were doing it right, now all of a sudden why are you getting them wrong? Any of those issues, first thing to do is to kind of slow down, see if you're showing enough work, see if you can find your error. Could be a copying error, could be a small arithmetic error, but showing your work when you start to make mistakes is going to really help you identify what the problem is. Sometimes it's small. It's not really about you don't know the math, it's you made a teeny tiny error. Okay, so talk to me more too if you're a little concerned about how much work to show, and we'll check your assignments as we go in class, and I'll let you know as I see them. That looks good, or that needs to show more. Okay, sorry about the detour there. Still the beginning of the term, so I want to give you as much helpful info as possible as we go through these. Okay, thanks for being patient. Number 60. Now, a little bit more challenging here, but the steps stay the same. We're still simplifying. The goal is to remove any parentheses, use distribution if we need to do that, and then combine like terms. So as we see 7, parentheses 3y plus 5, parentheses, or 7 times the quantity, 3y plus 5, plus a negative 25y. We see two sets of parentheses. We see the one that's holding the 3y plus 5 together, and we see the one that's just holding negative 25y. This first set of parentheses calls for distribution because we've got a 7 multiplied across addition. We want to apply that multiplication to both of these pieces being added together. The second set of parentheses are what I call just a placeholder. They're just kind of identifying that, hey, I've got a negative 25y. So you don't have to do anything with that one. The distribute here would look like 7 times 3y plus 7 times 5. And then as you look at the plus negative 25y, if you're comfortable, you can write it without the parentheses, plus negative 25y. It's just a way for the author to kind of get your eyes to focus on, oh, I'm adding a negative here, which you can expect because we're in the section on learning how to add positives and negatives together. So now, again, we've got some parentheses still, but we're looking, they indicate multiplication. So let's go ahead and work that out. Technically, we're using the associative property to regroup these. Instead of 3y being grouped together and multiplying those first, we're going to regroup and multiply the 7 times 3 first. So it's really a 7 times 3y plus 7 times 5 is just 35. Plus a negative 25y. Again, this is more steps than you have to show in your own work. I'm just trying to make it really clear what's happening here. We're not distributing that 7. We're going to regroup, because it's all multiplication. Now, 7 times 3 out in front here is going to become a 21y plus 35 minus 25y. We can use the commutative property to switch these around. The reason why I would is because I'm looking to combine like terms. Okay, so I'm going to switch those around. 21y plus, now notice, this is going to be critical here. I kind of jumped into, ooh, plus a negative is the same as subtraction. What I really want to do for myself is keep that negative attached to the 25y, because then when I move it, there's no question where that negative goes. It stays with the 25y. So it's plus a negative 25y and then plus the 35. So I just switched those places. And again, the reason why I did is because then I can, when I add left to right, order of operations, I've got my like terms next to each other. This is an example of this step here where I regrouped more than you need to show. The step here from red to black where I switch these two terms, more than you need to show. But whatever it takes to help things make sense to you as you're getting started, that's what I want you to do. I'm going to go ahead and copy exactly what I have here so I don't make any errors, as if I try to do it all mentally. And I've got like terms. That's what I'm doing now. I've taken care of all the parentheses, combining like terms. I've got a positive 21y plus a negative 25y. I've got different signs, which means I'm going to find the difference, which means I'm going to subtract. Difference and subtract mean the same thing. So I'm going to take 25 minus 21. This is actually our first example in the notes where the bigger number wasn't written first. So 25 minus 21 is what we're doing here. That gives me 4. Because it's y's, it gives me 4y. Okay, so it was 21y plus a negative 25y. It's really 25y minus 21y. That gives you 4y. And then let's look at who had the bigger number, who had the bigger sign, sorry. 25 had the bigger sign, so this becomes a negative 4y. And we still have the plus 35 out here. And these are not like terms because they don't have the same variable. This one is without, and this one is with a y. So our final version is just negative 4y plus 35. Now at this point, and I know I'm getting near the bottom of the screen here, you could write it as 35 plus a negative 4y, or even 35 minus 4y. All those would be acceptable. On an exam, I would accept any of those three answers. You'll see me and the book most likely tend to put the variable piece in front and the constant piece in back, simply because we know where we're headed. We're headed to in Math 60 through Chapter 4. Chapter 4's focus is linear equations, and to make the most out of our knowledge of linear equations, we put that variable piece first and then the constant afterwards. So just planting some seeds as we go. Take a moment to make sure you've copied everything down you need for your notes. Talk it through with somebody, because at the beginning of the next video, we'll have you try that number 54 down near the bottom of the page. Okay, we'll see you there.